Okay, here are some examples of simplifying rational expressions. Remember, rational expression is just a fraction, so we're just going to simplify these fractions or reduce them to lowest terms. And just like we do normal fractions, we want to divide out any common factors. And if we look at this first example, we've got two simple trinomials, and I think we can factor both of those, and then if we have common factors, we can remove those or make them 1 over 1, which is 1. So this is going to be something like this. When we look at our simple trinomials, we know these x times x is x squared, so I analyze my signs. This tells me these signs are going to be different. Sign of the largest is negative, so I got negative positive. Multiply to give 3, so 3 and 1 differ by 2, and we always want to check it. And that's negative 3 plus 1 is negative 2, and that's negative 3, so that checks. And the bottom, we can factor this also. This tells me these signs are going to be the same. They're both going to be positive. Multiply to give 4, but add it to be 5, so I'd say 4 times 1 would work. And there you go. So now we have the top and the bottom factored. And if we just look at this part over here, x plus 1 over x plus 1 is just 1. Sometimes we say they cancel out, but really what they're doing is they're making a 1, and 1 times anything is that anything. So there's your final answer. Is what's left, x minus 3 all over x plus 4, and we don't need the parentheses anymore. Okay? Okay, take a look at number 2. And again, we want to factor the top and the bottom, and then make any common factors on the top and the bottom 1. So this looks like this is going to be the difference of perfect squares, because 36 is a perfect square. The square root of 36 is 6. And the square root of x squared is x. So I know I'm going to have the product of the sum and difference of these little numbers. That's my good old difference of perfect squares, method number 2 in our factoring methods. So it's going to be the sum and the difference of these little numbers, x and 6, x plus 6, x minus 6. And on the bottom, looks like I have a simple trinomial. Actually, it's a trinomial square, but I'll write it out so I can simplify it a little bit easier. So x and x. And the square root of 36 is 6. Square root of x is x, and I have twice the product. Twice 6 is 12 with a negative, so I was going to have negative for both of these. Or we could say this tells me the signs are the same. They're both negative. They multiply to give 36, 6 and 6, which is the square root. So either way you want to do it. And again, if you look at this, x minus 6 over x minus 6 is 1. So those kind of work each other out. And what's left is x plus 6 over x minus 6. So there you go. Okay, number 3, looks like we've got two general trinomials, but these are easier general trinomials, so these are ones you can kind of noodle out by trial and error because there aren't too many possibilities when we have a prime number here and here, and here and here. So we'll start with the top, and I know the only way I can get 3x squared is by 3x times x. Now my signs might be a little more challenging here because I've got different signs. So I kind of noodle this out and try trial and error, but the only way I can get 2 is 2 and 1. So either my 2 is going to go here or here, and I can kind of just pencil that in until I decide just to try it. So if I try a 2 here and a 1 there, 3 times 2 is 6. Now their product will differ by 1. So if I do 3 times 2 is 6 and 1, those differ by 5, so that's not working. So I'll erase that. I did it real lightly just to check it, and then I'll try the other way. Let me try 2 over here, and 1 over here, and 3 times 1 is 3, 2 times 1 is 2, and those differ by by 1, so it looks like that's going to work. So it looks like I can ink those in now. And then I want this to be positive, so I want the bigger one to be positive. So 3 times 1, 2 times 1. So 3 times 1 is bigger, so I'll make that positive so it will match with this. And this is going to be negative, because the signs will be different because they multiply to give a negative. So when you check it out, you always check it. 3x times x is 3x squared. 3x minus 2x, outside inside, is positive 1x, and then negative 2 times 1 is 1. So you can kind of work those out in your head, or by trial and error, without using that longer process we use for general trinomials. This one's a lot easier because my signs are all positive. I know 2x times x is the only way I can get 2x squared, and the only way I can get 1 is 1 and 1. And all my signs are positive, so all these signs must be positive. There's no negatives involved here. And you can just check that. 2x times x is 2x squared, and then outside 2x plus 1x is 3x, and 1 times 1 is 1. And then again, you can see we have common factor in the numerator and the denominator of x plus 1, so that becomes 1 in reality. And my final answer is just what's left on the top. 3x minus 2 all over 2x plus 1. Okay, and the last one here of our 4 examples. Looks like we use a common factor, so I can factor an x out of the top. So I've got x, and what's left is x minus 2 on the top, x minus 2. And it looks like the bottom is the difference of perfect squares, x squared, square root of x squared is x, the square root of 4 is 2. So it looks like I've got the product of the sum and difference of those little numbers, the sum and difference of x and 2 plus 2x minus 2. And again, we've got a common factor of x minus 2 on the top, so that's what we can simplify or reduce out. And what's left? X on the top and x plus 2 on the bottom. Now on all these we could actually write the restrictions of the domain, so you should be aware of that. So I'll go back and catch all these up right now. Any value of x that makes the denominator 0 is not allowed. We can't have 0 in the denominator. So if x is negative 4 plus 4 is 0. So x cannot equal negative 4 or negative 1. Because a negative 1 plus 1 is also 0. So we can't have that. So those are what we call restrictions on the domain. Over here, x cannot equal. And if I have 6, 6 minus 6 is 0. If I've got negatives, and that's the same thing. So it's the same 1. So x cannot equal 6. In either case, 6 minus 6 is 0. We can't have that. Now over here, it's a little more complicated because we've got a fraction over here. So x cannot equal. And if you're not too sure, you could just always do a little equation. Say, well, 2x plus 1 cannot equal 0. Then if I subtract 1, 2x cannot equal negative 1, and then if I divide both sides by 2, x cannot equal negative 1/2. So negative 1/2 is one of the restrictions, and negative 1 is the other restriction. Because negative 1 plus 1 is 0, and if I put negative 1/2 in here, 2 times negative 1/2 is negative 1 plus 1 is also 0. And the last one, x cannot equal positive 2 or negative 2, so I could just say plus or minus 2. So these are restrictions on the domain. These are values that will make the denominator 0, and that's a no-no. We can't have that. Okay? So I hope that all makes sense. Those are 4 pretty good examples of simplifying rational expressions.